8 years after arriving at Jupiter, NASA's Juno mission is still doing something few spacecraft ever managed to do. It keeps making the solar system feel new. What began as a mission to understand Jupiter's origin and deep interior has evolved into something much bigger, a roaming investigator of the entire Jovian system, revealing that the largest planet in our solar system is not just massive, but restless, violent, and far more complex than scientists expected. NASA says Juno completed its primary mission in 2021 and then entered an extended mission focused not only on Jupiter itself, but also on its rings and several major moons, including Io. And now, in this Year 8 update, Juno is delivering two stories at once. One is happening on Jupiter, where the spacecraft is probing the giant planet's northern atmosphere, polar cyclones, and stratospheric structure in ways no previous mission has managed. The other is happening on Io, where Juno has captured stunning new images and infrared data, revealing that this moon is even more violently alive than scientists realized. NASA reported in April 2025 that Juno's new data sheds light on fierce winds and cyclones in Jupiter's north, while also, for the first time, revealing Io's subsurface temperature profile. Then, in January 2025, NASA announced that Juno had spotted the most powerful volcanic activity ever recorded on Io. That is what makes this update so remarkable. Juno is no longer just telling us what Jupiter looks like. It is showing us how Jupiter works, how Io vents internal heat, how storms on a giant planet organize themselves, and how one moon can look almost frozen in a photograph while hiding an inferno just below the surface. The images are stunning, yes, but the science behind them is even more unsettling because it suggests that both Jupiter and Io are still keeping major secrets. Year 8. Why Juno Still Matters. By the standards of planetary missions, Juno should already have secured its legacy. NASA's Juno science pages note that the spacecraft transformed our understanding of Jupiter's interior structure, atmosphere, auroras, magnetosphere, and polar cyclones during its prime mission. JPL's mission summary adds that Juno revealed an atmospheric weather layer extending far below the visible cloud tops and a deep interior with a diluted heavy element core. That alone would have made Juno historic, but the extended mission changed the scope of the mission entirely. Instead of ending as a Jupiter-only orbiter, Juno became an explorer of the broader Jovian system. That change in mission profile matters because Jupiter is not just a planet, it is a system. Its magnetic field is immense, its radiation belts are the strongest around any planet in the solar system, its atmosphere is layered and dynamic, and its moons are worlds in their own right. NASA explicitly says that in the extended mission, Juno has continued investigating Jupiter while also studying its faint rings and several Galilean moons. The result is that Year 8 no longer looks like an aging mission collecting leftovers. It looks like one of the most productive, late-stage planetary missions NASA has ever flown. There is also a psychological shift here. Most of the public still sees Juno mainly as the spacecraft that sends back beautiful portraits of Jupiter's cloud tops, but the mission's recent science updates make it clear that Juno has moved far beyond visual spectacle. It is now combining microwave data, infrared mapping, radio occultation experiments, and repeated flybys to build physical models of how Jupiter and Io actually behave. In other words, Juno is no longer just looking, it is diagnosing. The Io flybys changed everything. The biggest shift in the Year 8 story came from Io. Io has always been famous for one thing. It is the most volcanic world in the solar system. But that description, while true, had become almost too familiar. People heard it so often that the shock had faded. Juno brought the shock back. During its extended mission, the spacecraft made close flybys of Io in December 2023 and February 2024, passing within about 930 miles, or 1,500 kilometers, of the moon's surface. Then, even from a farther flyby in December 2024, Juno's instruments continued seeing extreme changes and new hotspots. NASA says those close passes, combined with the newer data, fundamentally deepened scientists' view of Io's volcanic engine. This matters because Io is not volcanically active in the way Earth is. Its volcanism is driven primarily by tidal heating. Io orbits extremely close to Jupiter, and its slightly elliptical orbit means the giant planet's gravitational pull changes constantly as the moon moves. NASA explains that this relentless gravitational squeezing generates frictional heating inside Io, melting portions of the interior and fueling what appears to be a nearly endless cycle of lava plumes and volcanic resurfacing. The moon completes an orbit in only about 42.5 hours, which means means the heating is persistent, not occasional. That is already extreme. But Juno's Year 8 update suggests the internal heat transport may be even more globally distributed than researchers expected. NASA's April 2025 update says Juno combined data from the microwave radiometer and the Jovian infrared auroral mapper, or GIRAM, and found evidence of still warm magma below Io's cooled crust at essentially every latitude and longitude measured. Shannon Brown of JPL described Io's volcanoes, lava fields, and subterranean lava flows as acting like a car radiator, efficiently moving heat from the interior to the surface. That analogy is simple, but the implication is profound. Io may not just host isolated volcanoes on a mostly cold shell. It may be bleeding heat through a far more globally connected system. The stunning images are beautiful and deeply alarming. Juno's visual imagery of Io is undeniably spectacular. The close flybys in late 2023 and early 2024 produced some of the sharpest spacecraft views of Io in decades, showing a surface that looks scarred, sulfur-stained, fractured, and constantly rewritten. Even the more distant December 2024 pass revealed visible color changes near the South Polar region, changes that NASA says are associated with volcanic hotspots and fresh activity. But what makes the images truly stunning is not just their resolution, it is what they reveal about motion over time. JunoCam comparisons between the earlier close flybys and the later data show that Io's surface is not just geologically active in the abstract, it is changing on mission timescales. Regions near the South Pole shifted in visible appearance over the course of months. That means Juno is not photographing an old volcanic record, it is watching a moon actively alter itself. That is one of the most remarkable parts of the Juno-Io story. Most planetary geology is slow enough that a human can understand it only through maps and age estimates. Io is different. Io changes fast enough that spacecraft can revisit the same region and see the planetology equivalent of fresh wounds. You are not looking at ancient lava plains preserved for billions of years. You are looking at a surface still being rewritten by internal forces powerful enough to flood, stain, and thermally transform terrain between flybys. And that is why these images land so differently. They are beautiful, yes, but they are also evidence that Io is not settled. It is in the middle of something. The most powerful eruption ever seen on Io, then came the result that pushed Io from active to something closer to unbelievable. In January 2025, NASA announced that Juno had identified a massive volcanic hotspot in Io's southern hemisphere. According to the mission team, the feature was larger than Earth's Lake Superior and represented the most powerful volcanic event ever recorded on Io. The hotspot was detected by GIRAM and was so intense that it saturated the detector. Alessandro Mura, a Juno co-investigator, said the data suggest not one single source, but a few closely spaced hotspots active at the same time, pointing to a vast subsurface magma chamber system. NASA says the feature spans about 40,000 square miles, or 100,000 square kilometers, and radiated well above 80 trillion watts of power. Those numbers are difficult to process. NASA stated that the eruption was releasing about 6 times the total energy output of all the world's power plants combined, and this was not a one-frame anomaly. In April 2025, NASA reported that the same historic eruption was still spewing lava and ash as recently as March 2nd, with mission scientists believing it likely remained active and expecting additional observations during a May 2025 flyby. This is the point where the word stunning starts to feel inadequate. Juno did not simply photograph lava, it caught evidence of an eruption so large and so energetic that even by Io's standards, mission scientists described it as mind-blowing. Scott Bolton said the latest flyby data really blew our minds and emphasized that this was the most powerful volcanic event ever recorded on the most volcanic world in the solar system. That quote matters because scientists do not say things like that lightly. Io is already the benchmark for volcanic violence. For an event there to stand out above the rest tells you how extraordinary this feature must be. Jupiter is still delivering groundbreaking science of its own. As dramatic as Io has become, the Year 8 update is not only about the Moon. Jupiter itself is still producing major breakthroughs. NASA's April 2025 report says that Juno has now completed 26 radio occultation soundings of Jupiter's atmosphere. In these experiments, radio signals are sent from Earth to Juno and back, passing through Jupiter's atmosphere on both legs of the journey. The bending of those radio waves lets scientists infer atmospheric temperature and density with surprising precision. That technique led to the first ever temperature measurement